Hello everyone, welcome to JS Career Code. I hope you are all doing great. Today marks the beginning of our mainframe concept series. I am excited to start this journey with all of you. For our very first mainframe video, let's understand one of the most important and commonly used concept in mainframe, GDG, which stands for Generation Data Group. Whether you're a fresher, a mainframe learner, someone preparing for interviews, or a working professional looking for a quick refresher, this video is for you. By end of the session, you will understand what GDG is, why it is used, and how it works, the important parameters, and even some interview questions. So, without wasting any time, let's get started. GDG stands for Generation Data Group. Before understanding the definition, let's first understand the problem what GDG solves. Imagine a company generates an employee report every day. If the report is stored using the same dataset name every day, yesterday's reports gets overwritten by today's report. Now, suppose a manager wants to see last week's report, or suppose today's report was generated incorrectly and we need to recover yesterday's version. How do we do that? This is where GDG becomes useful. A GD A GDG is a collection of related datasets maintained in a chronological order. Each version of the dataset is called generation. Instead of overwriting the old data, mainframe automatically creates a new version and maintains previous version for further reference. Why GDG? Now let's understand why organization use GDG. The first reason is maintaining historical data. Many production jobs run daily, weekly or monthly, and organization often needs access to the previous outputs. The second reason is backup and recovery. If today file contains incorrect data, we can quickly go back to a previous generation. The third reason is audit requirements. Industries such as banking, insurance, healthcare are required to retain historical data for compliance purposes. And finally, GDG automatic version management. Developer don't need to manually create new dataset names every day. Mainframe handles everything automatically. This saves times, reduce errors, and makes maintain much easier. A GDG base is the catalog entry that manages all generation. Think of it as a parent folder. The GDG base itself does not store any actual business data. Instead, it stores rules and control related to the generation. For example, it determines how many generations should be retained, whether all generation should be physically deleted, and how generation management should be given. Simply put, the GDG base acts as a manager of all generation. Generation is an individual version of a dataset. Let's assume we generate a payroll report every month. January's report becomes one generation. February's report becomes another generation. So all these version belongs to the same GDG family. This allows us the access historical reports whenever it required. Instead of maintaining multiple datasets named manually, Mainframe manages them automatically. In GDG base, we have emp.file. In the generation, we have created three versions of it, which contains first, second, and third generation file. Relative generation number. One of the biggest advantages of GDG is that we don't need to remember long generation names. Instead, we can use relative numbers. GDG plus 1 written as GDG plus 1 represents the next generation to be created. GDG of 0 represents the current latest generation. GDG of minus 1 represents the previous generation. GDG of minus 2 represents the generation before that. So this makes coding simple and maintenance easy. Programmers can always refer to the dataset relative to the current generation without worrying about the actual generation names. Next is absolute generation name. While programmers usually use relative generation numbers, Mainframe internally creates an absolute generation name. For example, employee file dot G0005V00. The G000 is a generation number, V00 is a version number. So here these names are automatically generated by the operating system. Normally, developers do not outcode these names because relative references are easier to maintain. Creating a new GDG base. Before using GDG, we must first create the GDG base. This is done using id camps and the define GDG command. In this example, the name specifies the GDG base name. Limit specifies how many generations can be retained. The scratch tells the mainframe to physically delete expired generation. No empty tells mainframe to remove only the oldest generation when the limit is reached. Once this command executes successfully, the GDG structure is ready for use. We have specified limit of 5, which states it can create only 5 generations and it can be retained. Okay, now let's understand the important parameters we used in this syntax. Name. Name specifies the name of the GDG base that is need to be created. Limit parameter specifies the maximum number of generations retained in a GDG. Scratch physically deletes expired dataset from disk. No scratch parameter removes only the catalog entry while keeping the dataset on storage. Empty deletes all existing generations when the limit is reached. No empty deletes only the oldest generation. These parameters are very important and frequently asked during the interviews. Okay, now let's move on to no empty parameter. No empty deletes the oldest generation when the generation limit is reached. Let's assume limit is set to 3. Currently we have generation 1, generation 2, generation 3. Now a new generation is created. Since no empty is specified, only the oldest generation is removed. So the results become generation 2, generation 3, generation 4. This creates a rolling history of datasets. This is the most common behavior used in production system. Next comes to empty parameter. Empty deletes all existing generation when the generation limit is reached. Now let's look into empty. Again, assume the limit is 3. We currently have 3 generations. When the next generation is created, all previous generations are deleted. Only the newest generation remains. Because of the behavior, empty is less commonly used in production environments. A GDG generation as PS file. A GDG generation can be created as a sequential dataset, also called as a PS dataset. We create it using GDG plus 1. When the job executes, mainframe automatically assigns the next generation name. This is the most common type of GDG generation. GDG generation as PDS file. So GDS generation can be created as a PDS file datasets by specifying DSORG equal to PO. To achieve this, although not as common as PS dataset, generations are supported and used when multiple members need to be stored. GDG of 0 always refers to the latest available generation. Whenever a program needs the most recent version of a dataset, GDG of 0 is typically used. It is commonly used as an input file. GDG minus 1. GDG minus 1 refers to the generation immediately before the latest one. This is useful for comparison, validation, recovery operations, and troubleshooting. GDG of plus 1. GDG of plus 1 is used to create the next generation. This is commonly used when a batch job produces a new output file. This system automatically assigns the correct generation number. Developers don't need to know what the next absolute generation name will be. Next, let's see some commands used in GDG. Alter command. Alter is used to modify an existing GDG. For example, if the business want to retain more historical data, the limit can be increased. Instead of recreating the GDG, we can simply use alter command. Syntax is alter the GDG name. If we are going to maximize the limit count from 5 to 10, we need to specify limit of 10. Next, delete command. The delete command remove a GDG base and all associate generations. The force option ensures that all generations are deleted as well. This command should be used carefully, especially in production environment. So the force option ensures that all generations are deleted. Next, we see listcat command. Listcat is one of the most useful IDCAMS command. It displays details such as GDG base information, retention limits, existing generation, catalog information. Whenever there is a GDG issue, listcat is usually the first command developer use for investigation. Next, we can see some error codes which generated during the GDG execution. Okay, so IEC 331I. It is this error generally occurs when a duplicate GDG generation is trying to attempted. It commonly happens during job restart situation. To resolve it, verify whether the generation already exists and check the restart point and delete unwanted generation if required. Then IDC 3012I, IDC 30091. These errors are generally related to the catalog inconsistencies. When these error occurs, run listcat, verify catalog entries, and recatalog dataset if necessary. Then IEC 141I. This error usually occurs when attempting to create a dataset that already exists. Most of the time, this happens due to incorrect restart handling or dataset naming issue. Always verify existing generation before running jobs. So that's it. That's a complete overview of a GDG in mainframe. Today we learned what GDG is, why organization use it, GDG based and generation, relative and absolute generation numbers, important GDG parameters such as empty, no empty, scratch, no scratch, and how to create a GDG and common IDCAMS comment, and we frequently encountered GDG errors. I hope this session helped you understand GDG in a simple and a practical way. Thank you so much for watching this video till the end. If you found this video useful, please take a moment to like, comment and subscribe to the channel. Also, let me know in the comment section what mainframe topic you would like to cover next. In our next video, we will be learning another important mainframe concept, the basic concept TSO, ISPF, SDSF, and QMF. So stay tuned, keep learning, keep growing. I will see you in the next video. Thank you and have a very wonderful day.